two new things. Today we're going to learn about static variables and we're going to learn about passing parameters by reference. So first let's go ahead and jump into it and let's take this last little block of code and put it into its own function. So what this is, this while loop right here, remember this is what simulates the battle. So what I'm going to do is go ahead and copy it, and I'm actually going to cut it, and I'm going to make a new function down here to put it in. And we're going to make it a void function. We don't want it to return a value. And we're going to call it simulate battle. And then we'll do parentheses because it's a function and our brackets for the body. So I'm going to go ahead and paste everything right here. And we're immediately going to get a bunch of errors because none of these variables are defined in simulate battle. The variables are actually defined up here in int main, remember? If we want them in simulate battle, then we're going to have to pass them in as parameters. However, we don't have to pass all of these in as parameters. For instance, this char turn isn't used anywhere else in int main. We made this variable solely for the battle simulation. So we'll go ahead and just copy it and move it down here to simulate battle. We can just put it there. There's other variables. These float human attack, human health, human damage, skeleton attack, skeleton health, skeleton damage. We don't use those anywhere else except the simulation. So we might as well just copy those down there and it'll make our actual main function much smaller and much easier to read. So we'll copy the human properties and put them right there. And we'll copy the skeleton properties and put them down here. The hotkey for cut, if you want to cut and paste, is Control X. And remember, to paste, it's Control V. Makes things much faster. So we can also take these float current human health and current skeleton health. We don't need them up there either. Probably could have just copied those the first time. Let me put this in the right spot. Feel free to pause the video if I'm going too fast. You can always pause and catch up or even work ahead if you want to. Okay, let's see. So there's a few things still up here. There's start skeletons, start humans. We're going to pass num skeletons and num humans in as parameters. Let's go ahead and take attack result. Attack result is not something we use in int main. It's something that is only used in this function down here. So I'm going to paste that right here. And you'll already see a lot of the errors are gone. The only errors we have now are num humans, num skeletons, and then our random engine. So we could pass the random engine as a parameter, but there's another cool trick we can do, and it's called using static variables. Now, the reason we want to use static variables is because if we, well, here, let me explain this a little better. What we're going to do is take this and copy it down in this function like we did before. So we're going to paste it right here. Now, it's going to work just fine, right? We're initializing our random engine here, we're getting our distribution right here, and we're using them and all the errors go away. And this will work exactly fine. It's going to do everything exactly as we want. But if we call simulate battle again, we're going to have to create a whole new random engine. If we call simulate battle twice within 1 second, then this random engine is going to give us the exact same random chance. Because remember, time null only operates on a per second basis. Each second, this value will change and give you a different seed. But if you call this twice within 1 second, so if we called simulate battle and then simulate battle again really fast, say we wanted to simulate 2 battles or 100 battles or something, then what's going to happen is we're going to get the same random chance values. If we don't want that to happen, if we only want to make this variable one time, all we have to do is type static here in front. And what a static variable is it's something special. It's not a local variable in the sense that it is here only for the duration of this function. Whenever this function is first called, it's going to create it. We're going to get our random engine and it's going to seed it with time. The next time the function gets called, it's not going to create it. It already has it. It basically holds on to this variable forever and it never goes away until your program ends. So if we call it once, call it twice, call it 3 times, it's only going to initialize it the first time. We'll still have the variable to use. It will still be declared and it will have been seeded the first time. We don't have to worry about anything else. It's just ready to use, and that's what static variables are for. If we had a static int int I equals 5 or something, each time we call simulate battle, it's going to be 5. Now if we say I plus equals 1, and then we do cout I, I'll go ahead and just tell you what this is going to print out. The first time we run it, we're going to get 6. The next time we run simulate battle, we're going to get 7. And the reason is, remember, it's a static int, so it's only initialized one time. We're going to get I equals 5 at the beginning, and then 5 plus equals 1 is 6, so we're going to see out a 6. Next time we call simulate battle, say this is our second battle in our big campaign game or something. The next time we come in, since it's a static variable, we don't initialize it again. We already initialized it once, and that's the only time we're going to initialize it. So now the variable is equal to 6 because of the previous time. It keeps its value. It retains its value each time you call it. So 6 plus equals 1, and we get 7. I hope that made sense. We're probably not going to use too many static variables, but it's a good thing to know. We don't have to make this static. We could make it static, but it's okay to reinitialize this because it doesn't depend on time. So now there's one last thing we need to do. We need to pass in these variables, num humans and num skeletons. Now we can't declare them in here because we're getting the input up here. So we're definitely going to want to use parameters. So we're going to type int num humans, int num skeletons, and then always remember, you have to do a forward declaration. We're going to get an error when we try to run this if we don't put our forward declaration up here. It's really nice to have all these functions up at the top because then if you ever want to see what one of these does, if you're in Visual Studio, you can just right click on it and click go to definition, and it'll take you right down to it and you can see the code. So the last thing we have to do is call simulate battle from our main function. So let's come up here to, let's see, where was it supposed to be? Right here. Simulate battle. And what are we passing in? Num humans. And as you can see right below this, it actually pops up the parameter list and it bolds the ones you're typing in. So if we press comma, it'll tell us the next one we're typing in. That makes it much easier. Then we type num skeletons. Okay, so now we're passing it in. And remember, num humans and num skeletons are completely different variables than this num humans and this num skeletons. We could have named them different things and it would have been fine. Remember, it makes a copy. It takes this num humans and sets it equal to the num humans up here. So the one we get from standard input up here makes a copy of itself basically whenever it passes it, when it gets passed into simulate battle. So let's go ahead and run this. It's not actually going to work, believe it or not, and I will show you why. Enter the number of humans, 10,000. Number of skeletons, 60,000. Beginning combat battle is over. There are 100,000, there's 10,000 humans left. That's weird. No humans died. And then look, it tells us 0 humans died and 0 skeletons died. Well, that's kind of weird, isn't it? Normally it works. It's worked every time. It didn't work this time. Well, the reason it didn't work is because num humans here and num skeletons here are completely different variables than num humans and num skeletons here. Remember, they made copies of themselves. This is called passing an argument by value. So what happened is, say we have num humans here. Num humans equals get num humans, right? And we typed in 10,000. So now num humans equals 10,000. Then right down here, we pass a copy of num humans to simulate battle. So we pass 10,000. It's going to simulate the battle, right? But this is a different variable. So down here in simulate battle, when it says num humans minus minus, it's going to subtract 1 from the copy of num humans, not the original num humans. So then when we go to print results here, we're going to be passing 10,000 humans, 60,000 skeletons, and it's not going to be correct. All we have to do to make it modify the original value and not a copy is to do something called passing it in by reference. So normally we pass it in by value. If we want it to change, we pass it in by reference. Now all we have to do is type an ampersand in front of the name. So we'll do it like this: ampersand num humans, ampersand num skeletons. And that's it. We are done. Now what happens is it doesn't make a copy. It doesn't make a new variable. The names still don't have to match. This could be num ducks and this could still be num humans and it would be fine. However, because we made it a reference, it's going to change the original value. It's actually, instead of making a copy, it's going to take this exact variable right here and pass it in. And it's going to mean that anytime you change anything having to do with num skeletons or num humans, it's going to change the original value. So now our program is going to work exactly like we wanted. Reference values are really useful whenever you want to do stuff like this and when you want to have a function that will modify multiple values. Because remember, normally a function could only return one value. So if we wanted to, we could have tried to return num humans, but we couldn't return num humans and num skeletons. So that's where reference parameters come in handy. Now we're getting an error, and the reason we're getting an error is because we changed our declaration here and we didn't change our prototype up here. Oh yeah, I've been calling these four declarations. They're also called function prototypes, just so you know. Just a little fun fact. And we'll put our ampersands there, and now everything is going to work fine, and our code is so cool. Our code looks much, much better. We're going to say 10,000 humans, 60,000 skeletons, and there we go. If I zoom in, you see we're getting, real values. All the skeletons died, 5,000 humans died. It's working correctly, just as it should. Now, this is pretty much all we're going to be doing with this program for now, I think. As you can see, if we go up to our main function, the whole thing fits in like 20 lines of code. It's so much smaller, it's so much better. This is what you want. This is how you want your main function to look. Look how easy it is to read, and we could put we definitely want to put comments, to tell the user this is the battle part or whatever. And then our code just becomes so much easier to manage. We're really close to having super readable code. The next thing we want to learn to make our code even better is something called classes. But we're going to learn a few more things before we get into classes, because there's some things that I think are pretty important for you to know for the next challenge.